Hello and welcome to our session at for the Kubeflow portion of our talk. I am Josh Bottom and really happy to be here. I work and volunteer as a Kubeflow community product manager. And today we're going to talk about streamlining machine learning operations with Kubeflow. In our agenda today, we're going to talk about what is Kubeflow and why market leaders are using it for their ML platform. We'll talk about the Kubeflow user survey, the results in benchmarking your ML platform. We'll do a demo and show how Kubeflow streamlines some of those workflows and simplifies operations. And then we'll go into what's coming in Kubeflow 1.7 and how to get involved in the Kubeflow community. So often, having supported, I think we have about 8,000 community members on Slack in Kubeflow over the last 4 years, maybe 14 releases that I've been involved in helping deliver. People ask me a lot, why Kubeflow, right? And I think really before Kubeflow, what we saw was that people were building environments where they had a lot of operational sprawl. So there were many tools or communities that they were trying to bring together. And there's a lot of great tools in there. You can see the list down here. But it would take months of analysis and integration to build, test, and document and develop the support process. And often this ended up with custom forks, limited portability between clouds. Kubeflow, on the other hand, is really designed to be a Kubernetes native ML platform. And it has a tool set that's integrated for what you might consider end-to-end workflows. It provides portability so it can run on many of the major clouds out there, whether it's AWS, GCP, Azure, IBM, even on-prem, even on your laptop, and it provides for Kubernetes efficiencies, which are real important and fit very well into this end-to-end lifecycle that I'll go into. So when you look at this, Kubeflow provides model building, and usually you're going to do that in something like a Jupyter notebook. What's nice about Kubeflow is that it runs on top of Kubernetes, and you can use this isolation and auto scaling to be able to run multiple Jupyter notebooks in isolated areas so you can have a multi-user environment. It also supports other notebooks. So instead of just Jupyter, you can run VS Code or RStudio. And then once you have done some experimentation in your notebook, obviously that gives you an interactive compute environment that allows for quick iteration of your code and be able to run things and see results. Once you get to a place where you need to do some training, Kubeflow then again leverages Kubernetes using custom resource definitions and operators in order to allow you to run your, let's say, PyTorch or MXNet or TensorFlow frameworks, be able to run those in a distributed manner. And some of the nice parts about Kubeflow is that you can add labels to what requirements are needed to run these workflows. Let's say you need a lot of memory or you need GPU, and Kubernetes primitives will allow you to automatically place those workloads on the proper node, scale them up, run those training jobs, and then scale back down. In addition, Kubeflow provides for hyperparameter optimization and AutoML through a tool called KTIB. And what that does is allow you to tune the parameters outside of the machine learning model parameters. So this can be very important. In one Kaggle model we saw in a demonstration, it improved a model that won $1 million in a Kaggle competition by almost 10% by running it through the hyperparameter optimization. So the point is that there's a lot of stuff, a lot of components to a machine learning model outside of just the actual framework that you're running, and often you can optimize that using tools like CATIB. Beyond that, Kubeflow provides an analysis tool called TensorBoard, and that provides a visualization of your data, and that allows you to see for patterns. And probably the most important, most used component, maybe the most important, is the machine learning pipelines. Kubeflow pipelines, very well built on Argo. There's also a secondary implementation using Tekton, but the idea is once you've done your experimentation, let's say in a notebook, or you could do it in VS Code, you can bring it over and then run each of your steps: load data, train data, model evaluation, and then prediction. You could run all those in separate Kubernetes containers, and basically then scale those out as you need to, and scale them back down, and have a sequence to run all those steps in your pipeline in a sequential way with, fault detection. If some particular load data fails, then you're going to know. You also have metadata tracking. This is important. There's a lot of components, not just your code. A lot of people think that you can just put your code in to get, and yes, you can. But what do you do with your data? Your data sets could be 100 gigabytes, could be, larger. So, you need to figure out where you're going to keep your data, and that's usually using Kubernetes storage classes, and storage volumes, persistent volumes. But the point is, you need some way to keep track of all those things together in a consolidated way. That's what metadata tracking can help you do, along with all the hyperparameters and potentially all the dependencies that you need. And then in the deployment side, Kubeflow has a component that now stands alone. It's called a K-serve, and it provides core inference with advanced inference functionality and model explainability and monitoring. So from that standpoint, you can have a pod that does prediction, or you could have preprocessor. So you have an application, it brings in some data, let's say a picture, it needs to be preprocessed, then to a predictor, and then have a post-processor. Each of those could be on separate containers. They could be deployed on different types of hardware. One could have a lot of RAM, one could have a CPU, GPU. You have different serving runtimes that are supported. So, whether it's NVIDIA or PyTorch or MXNet or XGBoost, you can support all those. But it also provides a V2 inference protocol that tried to standardize all that and has done a good job of making a universal, simplified way to be able to deploy these models. And this works both in the deployment side and then separately in the training operator, where we provided these uniform ways to be able to use deployment. So that means that for us in the Kubeflow community, if we have a bug fix or whatever, we can put those in and you get them in and it supports all the different frameworks. But for you as an operator, again, you don't have to learn a bunch, how MXNet works this way, and TF serving is this way, and PyTorch or PyServe is this way. Now you have one protocol basically that you can use from an operational standpoint. It has serverless auto scaling. So this is nice because you can scale up or scale down to 0, and you also have interface with all the cloud-based storage, along with an inference graph that allows for traffic splitting and ensemble, canary rollouts, and then again with the explainability, an outlier explainer to explain what parts of your model are really driving the parameters. Bias detection, adversarial detection, outlier, and drift detection. But really, all of that comes down to Kubeflow helps you build more models, have better business results. That's what the executives are looking for. And from an architectural standpoint, it reduces your MLOps sprawl. When you look at it from an architectural standpoint, you have these ML tools up here that we've talked about. Kubeflow helps provide these operators and CRDs and other types of tools that run on these types of dependencies, Istio, Argo, Prometheus, all this running on a Kubernetes platform. And then that allows you to run on GCP, AWS, Azure, on-prem, local. And from a software component, again, if you just saw a picture of what you might see on the Kubeflow .org docs, this is a picture that you would see from our GitHub space. This is where we keep all our code and everything, and manage all our projects from. But this is just showing all the different components that are involved and what gets deployed. It uses, and we provide two different ways, actually multiple ways to install, but we provide two primary ways for the open source environment. One is a single line of code that will deploy all the software that you can see here. You can see that not all of them are running the same release. That's because each of these are separate independent software projects that then are all tested together and developed into various Kubeflow releases. So, the central dashboard is 1.6, but the training operator might be running 1.5 because that's just its own internal development cycle, whereas Kserve might be running 0.8 and Kubeflow pipelines running 2.0. So you have a lot of different components that are put together, tested, documented, and then delivered. This is just showing you that we use manifest and customize to do this. And customize provides a lot of flexibility because you can override the defaults of the parameters that you're using to deploy with. This gives a lot of advantages, not just because if you have some changes that need to come in later, it's easy to make adaptations, but also for distributions or vendors that support Kubeflow. I'm going to move on now quickly to Kubeflow users. And these are just some examples of people over the years that have written different blog posts or done presentations, LinkedIn, Spotify, Gojek's, Intuit, and they've talked about doubling the effectiveness of their ML engineers. So, if you know how hard it is to hire an ML engineer, much less pay them, knowing that you can double the effectiveness of them would be good. Teams are producing 7 times more experiments. So you can see that they're able to turn their projects around faster. Gojek's, which is kind of like an Uber for Southeast Asia, 100 million ride-hailing bookings a month. So it scales up and allows you to do this recommender service to help you optimize your profits. And then also with Intuit, they have run Kubeflow and used the advanced orchestration experimentation. They run in production with Kubeflow with several applications. I'm going to move on now to the Kubeflow user survey. Hopefully this will give you an idea of who uses Kubeflow and why. From a perspective, we have people from all different types of applications, whether it's mining or marketing or real estate or particle acceleration or biometrics, bioinformatics. You will see healthcare, many different people, large, small companies, startups disrupting. But basically, the main people that we talked to in the Kubeflow user survey this year, which had about 150 people respond to it, were our ML engineers. And I've done this survey. I've thought it up, created it, write all the questions for it. Could be better, but it's basically we do it as we can. It's been ML engineers giving us the most insights. Then architects, then data scientists and analysts. I'd like to kind of grow this a little bit more because I think the end user is important. We focus a lot on the platform, but you can see, Kubernetes platform, DevOps engineers, engineering managers. We get a lot of feedback. I take this feedback to heart. The documentation needs to be improved. The tutorials could be more extensive. We need to work on security, installation, support. These are all things that you would expect from an open source project. We give you a way to solve these problems using commercial implementations, but a lot of people, open source means that they want to do it themselves and try to do it for free. And that does take a little bit of work. But if you work with some of the vendors, it's relatively easy to get up and running. The other gaps that we've been told in the survey for this year was on ML activities and workflows. So monitoring models, which to me probably says that people are putting more models into production, which is good because they need to monitor them. Connecting data pipelines to ML pipelines, that makes a lot of sense. I'm trying to bring in my data, transform it, get it ready, and then put it into an ML pipeline. Manually building pipelines, having to manually build all the separate Docker containers can be cumbersome. We're going to show in the demo how we can simplify that through a tool called Kale. Converting tuned models into served models, hyperparameter tuning and training models. So that gives you an idea of some of the gaps. And then what are we really trying to focus on probably is that the average lifespan for a model in production tends to be 3 months or less. You can see here, some people put it in for a week, some people put 13% a month, another 26, 3 months. So more than half are replacing within 3 months. And I think I went one too fast. What percentage of your models were successfully deployed into production and delivering business value? So what's interesting on this one, and this is probably one way to measure the community, is that about 30% of the people right here are getting 75% of their models into production. So that's a victory, right? I mean, anybody that's worked in IT for any amount of time, if you're getting 75% of your projects into production and delivering value with machine learning, that's pretty good. That's a best-in-class type of people. But about 30% aren't getting, are only getting 10% of their models into production. So, this could be people that are just starting off, or they could just be using components inside of Kubeflow and that don't need to go to production. So you could just be using Kubeflow for its notebook and not using it for serving. So, and it's designed to be that way, where it's composable. But really what we want to do is kind of drive people up more into this 50% or more. So hopefully we'll see this increase, and we have. And then versioning is important, because think about this. If you've got 10 models and you're deploying, having to deploy those again every 90 days, and it takes 15 iterations, I mean, that's 150 iterations every 90 days. You've got to track all those, not just the code, but all the data that was going along with it, because you can't reproduce your model without your data, as long as with the hyperparameters and all the dependencies. So that's important, is to know that. So I'm going to jump into the demo, do this for a few minutes. Hopefully you'll be able to see this. I'm using a system called, it's from Aricto. It's a company I used to work for. I don't now, but they are a market leader in Kubeflow. And they produce a couple different systems that make it easy to get started. It deploys the 40 pods for you. In my opinion, if you're just checking out Kubeflow, either Aricto's Kubeflow as a service or their mini KF are a quick way to spin this up. Kubeflow as a service from Aricto is free, and you can kind of walk through some of their tutorials very quickly. So in 10 minutes, you get to this dashboard. You only have to answer a few questions. It takes some time to deploy everything onto Kubernetes and into an environment. But anyway, you get to this dashboard, which is a little different than the standard open source Kubeflow. So this is a distributions view of Kubeflow. So there's a little advertising on here from Aricto. That's fine. But most of the stuff that's over here at the top and on the left is going to be what you're going to be seeing on most of the other distributions. One of the first things is Kubeflow provides this namespace isolation. So for enterprise, what you may hear in the market is that Kubeflow is a little bit complicated to get started with, and it is. I mean, I'm not going to say that it's as easy as some of the other ones, but really what it's designed to do is scale to an enterprise grade. And quite frankly, enterprise grade requirements are complicated, right? So when you talk about networking and storage and authentication and authorization and isolation and all those things, you need those baseline parameters to be able to be implemented properly in order to scale up. And so there's a little bit of a ramp up time. And so people that are using Kubeflow, they really need to be Kubernetes kind of platform folks before they start to be really successful, or they need to work on one of these services like Kubeflow as a service, or Vertex from GCP or some of the others. But the reason why I bring this up is this brings into this isolation that allows you to integrate with your single sign-on. You put in your name, your credentials, and there you're assigned to some namespaces. And now I'm isolated from other users. They can't see what I'm doing, right? But I could have a shared namespace. So if I'm a part of the ML engineering namespace, I can share it with my buddies. They can see, and they all can share notebooks or whatever they're working on. Now, over on the left here, you can see, besides having this isolation at the top, is all the components in Kubeflow. Notebooks, which we're going to go into a bit. TensorBoard, which we talked about. This is the visualization of your data. The models, this is the models that you're running into production. Snapshots, this is a proprietary extension from Aricto, but it's very nice because it gives you a consolidated snapshot of all your model attributes. Volumes, this is the persistent volumes that you're using. As you know, one of the most important things when you're using machine learning is the ability to manage your data, and putting it into persistent volumes and being able to get into a volume manager and bring files in or out, or modify them on your laptop and then put them back into the volume manager, and then allow you to use those in your scalable Kubernetes environment. This gives you a lot of flexibility. That's what the volume manager does. The experiments with AutoML, this is your hyperparameter tuning in your AutoML. I'm going to go and give an example of that in a bit. And then these next four are all with Kubeflow pipelines. Experiments, kind of your higher level piece of running Kubeflow pipelines. You have an experiment, then you have a pipeline. This defines exactly, what your steps in your workflow are. Your runs, this is if you run your pipeline multiple times, you're going to see these runs, and you can then bundle those up into experiments. And then you can have reoccurring runs, right? So runs that run every morning or every afternoon. You have artifacts and executions. Again, this is a way to see all the metadata associated with the runs or executions that you've done, and it gives you a lineage explorer so you can see how they're all interrelated, and then some metrics. I'm going to go in and show in the notebooks. This is kind of the notebook screen. I'm going to try to go quickly here. But I've got two notebooks running. This is the notebook that I have set up. I have a couple of notebooks. They're both Jupyters, how old they are, the last activity, what image I'm using. So as you know, you need to run in Kubernetes on a Docker container, or whatever, however you want to call it. It doesn't have to be Docker, but generally one that will interface with Kubernetes. But you have to have an image. You can build this on your own or use a pre-built one. Whether you're using GPUs or CPUs, what's the memory that's being utilized? This will tell you all the volumes that are associated with it. You can connect into this. You can hit stop, or you can throw it away. That's what the trash button is for. I need to move something here so I can go in. I've already started one of these, but before I do that, let me just show you how you can go in and configure this, because it's important that the end user knows that they can go in and configure this. So you give it a name, and you tell it what namespace you want to be in. This is usually pretty much set up for you by administrator, but your name could be, demo. And then you can pick what image you want. You can either do a custom image, or you can pick one of these, as I talked about before. And you can pick from a list of images, right? So those will have all the dependencies if you want one that has Jupyter or GPU functionality. You have the ability to set your CPU and your RAM here. You can also set your GPUs. You have a workspace volume. So often you need to be able to have some place to have persistence for your code. This is a great place to put it, is in this workspace volume. And then for your data, you can attach other data volumes or make one that you want. You can have configuration options here, various options for affinity and tolerations, if you're familiar with that in Kubernetes. Again, you may not want to run a lightweight type of application on a GPU node. So you can put this taint or toleration. I don't want to run that, so you can be more efficient in the way that you run. Then you hit launch. I've already done that, and you get a notebook basically that looks like this. I've already gone in through the terminal here and downloaded some data. You can see I've brought in some different examples and data associated with that. And in this example that I'm going to walk through, because I'm going to show you now how to build a Kubeflow pipeline, basically what we've got here is this Kaggle competition for open vaccine, which COVID-19 mRNA vaccine degradation prediction. And what this model does is it basically has tokenized or identified each of these branches or bases, the bases of this molecule, and put them into a sequence that then you can determine whether it's prone to cut or safe from degradation. So your model is going to go through and see if these bases are prone to cut or safe from degradation. So the first thing that typically you do when you're in a model like this, or you're building a model, is you want to install your requirements. I've already done that. I've downloaded all these, and you can see there's a bunch, whether it's TensorBoard or TensorFlow or Keras here. You can see some of these things that have been downloaded. You get all those down, right? And you bring all those in. That's automatically inside that install pip packages, the command that we did up above. So we've gone through that, and then you do your imports. Well, in this case, and you all have probably seen this before, where you run in, you have this problem where it doesn't find a component. You have to restart your kernel sometimes. So this case, after I've done my imports, after I've done my package install, I need to restart my kernel and then rerun this cell, and it would execute fine. The next thing is I'm going to bypass this hyperparameter tuning, because that's the second part of the demonstration I'm going to show. Is I'm going to go to this load data component, and really what I want to be able to do is I want to, from this code that's in this notebook, I want to build a pipeline that I can rerun, perhaps every day, perhaps it's some sequence that makes sense, but it's going to load in some data. It's going to pre-process that data, do model training and model evaluation. So I want to be able to get to a containerized pipeline that looks like this from the code that I'm building and experimenting with in this notebook. And so as I go through this notebook, you'll see that I have this load data portion, and all the code that comes after this is all associated with this load data. Well, Kubeflow and this Ericto extension here, which is open source, called Kale, enables you to do this very easily. And what Kale does, if I click on this and turn it on, which I have, it allows me then to use this little icon inside of each of the cells to tag a cell with a type of function that it does. In this case, I'm going to tag this cell right here as a pipeline step. So it's going to be part of my pipeline. And I give it a name. It's an arbitrary name that I make up, load data. What it depends upon doesn't depend upon anything, because it's the first step in my model, and whether it needs GPU. And I can identify some deploy configuration. Once I have that done and tag this, all the code that comes after this tag basically is going to be automatically put into a pipeline step called load data. But I need to do this for other code that's in here as well. So I need to be able to go in and build a pipeline step for pre-processed data. So I do the same thing for this pre-processed data portion. I say the pipeline step is called pre-processed data. What it depends upon, in this case, because it depends upon and must wait for load data to run, it's gonna depend upon load data. And now I've tagged my pre-processed data step, and then I will tag my model training step here. So again, I go in, I tag this as a pipeline step. I give it this model training. I say it depends on pre-processed data. And now all the code that comes after this tag is going to be put into a container called model training. And then finally, model evaluation, right? And now, if I want to build a pipeline, all I have to do is hit compile and run here. And when I do that, you'll see that it validates my notebook. It takes a snapshot of the complete environment. This is one of the nice things about the Ricto solution, but others probably have something similar, where you're now snapshotting the notebook, the code, the data, the hyperparameters, and the dependencies. It compiles the notebook, it uploads the pipeline, and it runs the pipeline. Now, I've already done this, and you can see that it's deployed this pipeline here: load data, pre-processed data, model training, model evaluation. I didn't have to manually build any of those Docker containers. I didn't have to put them up into a repo and then write the pipeline's DSL to make all this run together, the domain-specific language to make all this together. All I did was click this button here, and it created this pipeline for me. So a huge step, and allows you to iterate very, very quickly. Is a big bonus for folks. Now, the next step in this is, after I have this running in the way that I want, is I want to be able to then go and do some hyperparameter tuning. To do hyperparameter tuning, one of the things I need to be able to do is give a pipeline metric. This is validation loss. I'm going to set this right here. Here's the pipeline metric. I go in, and instead of saying this is a pipeline parameter, I say it's a pipeline metric, right? And then the next piece that I do is I go back up to the top, and you remember I had these pipeline parameters. I go and set these, and this is my learning rate, my epochs, my batch size, right? And so now if I go into Kale, I turn on my hyperparameter tuning with Katib, and look how nice this is. Right now, I can set up my search space parameters. And so if I want to set my learning rate between a min and a max and what the step size is, and do it in a range or a list, I've got that option. And I can do the same thing for epochs, batch size, dimensions, dropouts, all these components that allow me to do this broad multi-dimensional search space to optimize this model. And then I can say, which of the algorithms I want to do, random, grid, or Bayesian, for the search algorithm. And then again, we're doing validation loss. We set that, we're going to minimize it, and we can talk about how many run parameters. So this will be the trial counts, the max trial counts, and how many we go to fail. So I've already run this before, and if you'll see, it brought out this search space parameter here. You can see these are all the different runs. Here's the validation loss. We want the validation loss as low as possible. Here's the learning rate, the batch size, the dimensions, the dropouts. These were all the hyperparameters that we were trying to optimize on. And it also, besides this graph, which is interactive, if I had a bigger screen, you could see it all together. It also gives you one that in a table format. These are all run as Kubeflow pipelines. The best tuned model with the lowest validation loss is highlighted in yellow. You can then see what your batch size, dropouts, and all the parameters were. And you can click on this button here, which will take you into the details of that particular pipeline that was the best tuned model. And even better than that, you can jump into this. And this is with all the pipelines that you create in Kubeflow. You have all this detail that comes with it: inputs, outputs, visualization details, volumes, logs. So you can see a lot of information here. In this case, you can go into visualization, and you can click right on to this rock URL. It took a snapshot of that complete environment. And now if I want to create this environment again, so I can use it for serving the model, because it's the best tuned model in the way that I want it, I just click on this to copy that environment. And now I can go in and build a notebook very quickly by just going in and pasting in that URL, and it brings everything in to what I need. And I can call this something like vaccine serving. And I just go down and hit launch. And in a few minutes, I'm going to get another notebook up. And this is great for experimentation of serving, that will have exactly my best tuned model and all its parameters in memory. Now, to serve this model quickly, you may remember we were at the bottom of this model before, and we were doing print validation loss was the last thing we do. Now we bring in some more Kale utilities to enable serving. And then through this command right here, we're going to serve this model, which you could just do kf serving equals serve model, close parentheses. But this has two pods we're going to deploy, a preprocessor and a predictor, and it's using a tokenizer. So one step I didn't show is that we went through and pre-processed the data again, but in the interest of time, I'm not going to show those couple steps. It doesn't take too long. But really what this now does is it dumps the model in a way that it can be recreated into a couple pods. And if you look at some of these commands, it's starting to do that. I've already run this before. It takes the snapshot, and you can see this is a TensorFlow model that is going to be created. And then it goes through and builds an inference server with two pods on it, a preprocessor and a predictor pod, and then it becomes available. So that's what this is saying here, that I've deployed my endpoint, it's available. And I can look at it here in KF server. We're going to go into that. That's one of the model. It's running in real time and we can run predictions to it. I've created some of this data here first and managed it. And now what I want to be able to do is send some predictions to the model. So that's what I'm doing in this command right here that I'm running. And if I go over into the model overview, I can see that this is coming from this right here, this component right here. I can see that I've got a predictor pod, a transformer pod. I have, it's both ready. These are my internal and external URLs to get to it. I have a lot of details here. I have more details on this that tells me what my CPU limits are, my memory limits, what type of runtime it is. I have metrics. These are Grafana-based metrics on both of the predictor pod and the transformer pod that we're running. So you can see the CPU utilization starting to spike because I sent that prediction to it, the memory utilization, as well as you can see here, this is for the transformer pod down here. These are all the same CPU utilization, the memory, as well as the request volume by revision. So anyway, we went through quite a bit there. I want to just say, we went through, we built the model in a notebook, we automated the pipeline building, we tuned it, we served it, and then we monitored. Just to finish up here at the end, there's just a couple of quick components that I want to go over. Just a reminder that this is Kubernetes based. So we're running Kubernetes 122 right now with Kubeflow 1.6. You need to be able to run Istio, Knative, Cert Manager, Dex, Customize. And as we come out with releases, really the releases bundle all this software together. Our idea is to introduce new functionality that simplifies operations and streamlines ML workflows. There's a bunch of places for you to engage, but Tuesday community meetings are probably the best. And you also have GitHub, Slack, and ways to email. And our community is a combination of users, working groups, and distributions. Distributions are people like AWS, Amazon, others that we'll talk about. The release team kind of holds everyone together and develops and delivers the contributors that do the code to work with the users and make sure that the code comes out. Now we have a strategic goal to grow Kubeflow 2x in 3 releases, or about a year and a half. We're doing that in the Kubeflow Summit. I'm wearing the shirt that I got last week because we had the Kubeflow Summit to define and improve the community deliveries, differentiate distribution value, grow new functionality, either organically or collaboration, and define and publish and track metrics along those lines. When you look at 1.7, we're going to develop easier pipeline building in Kubeflow 2.0. So you can imagine we've already done I think it's about 18 releases of Kubeflow pipelines. Now we're going to 2.0. We're going to revamp the APIs, make the authoring of pipelines even easier and faster, both the front end, the back end, and the SDK. We're going to deliver more collaboration and functionality, either with other communities or by ourselves, and grow it organically. We're going to update the dependencies, like to go to Kubernetes 125, and add more security and improve the docs. That was one thing that people really asked for. And you can see some of the components here that we're talking about. Kubeflow 2.0 beta will probably be there. Notebooks may become something called workbenches. We're also adding in more monitoring, probably registration, model registry and feature store. You're seeing things like Ray. If folks are interested in Ray, working with Kubeflow, that was a very popular topic last week. MLflow integration, or Bento ML for serving, or Feast for a feature store. And we continue to grow our process. I think that's real important to know. And we have the largest release team we've ever had. We have more contributors. And then also, we just in the Kubeflow community, we had a proposal. Google's been running this project in the steering committee for quite some time to donate Kubeflow to become a CNCF project. The application is now open for comments in this pull request. And my kind of comment on this is that, this provides, this migration to the CNCF provides a path for strategic growth for the community, and it's something that we need. So you can learn more about Kubeflow in the Slack. It provides, so join the Kubeflow Slack. You can find it and easily join. If you can't find it, email me or get to me in LinkedIn. You can attend Kubeflow meetings. They're open to the public. I really recommend, you can run that tutorial that I just showed. You can get it up and running in less than an hour. So it goes pretty quick. It takes about, let's say, 10 to 12 minutes to get the environment up, and then you're downloading, and you can be inside that notebook within 20 minutes, less than that. And then running through those examples as I did, build a pipeline. You'll be building your first pipeline within 30 minutes. And then attend some of these Kubeflow events. Now, one slide that I did not show, I just want to see if I left it out. I apologize. No, I can't find it right now. This one. For some reason, I skipped over this one. I just also want to show that there are all these distributions, and I always like to promote these. These are folks that have made a lot of commitment. And, if the open source is too much for you, or you want some support, you can work with AWS or Google or IBM or Nutanix or IBM OpenShift, Aricto, Canonical, or Oracle. All of these provide support in various stages of Kubeflow versions. They provide documentation. So you have a commercial way to go and get support for the open source. So that's one thing that I like to make sure that people know, that Kubeflow is a very broad community with first-class users and documentation support from these distributions of market leaders. So I think that's basically it. Hopefully this was helpful for you as a Kubeflow review. Again, I'll just bring up these distributions as we close and see if there's any questions.